Today we are going to be learning about how to find the area of a region bounded by two curves. This is the formula you will use to find the area of a region between two curves. A and B are the points that the region will be bounded from. A is the lower value point and B is the higher value point. Inside the parentheses are the two functions that create the two curves that cross to make the region. The curve on top always goes first. In the case of the example graph, function g of x has the top line, which is why it comes first. Function f of x has the bottom line. This is why the function f of x will be subtracted from the function g of x. Now let's go through two different example problems step by step to find the area of the region bounded by two curves. First, you want to find the points of intersection. This is done by setting the two functions equal to each other and solving for x. First, get all the values on one side so that the equation is set equal to 0. Factor. In this problem, we end up with 2 points of intersection, one where x equals -2 and one where x equals 1. These two values give us the points that the area of region we are finding is bounded by. Before we can use these points, though, we need to figure out which function is on top and which function is on the bottom. We can figure this out by graphing the two functions on one graph. Of the region bounded by the points -2 and 1, the function f of x equals 3 minus x squared is the top curve, and the function g of x equals x plus 1 is the bottom curve. Now that we know which curve is on top and which curve is on the bottom, we are going to plug the functions and the points of intersections we found into the formula we learned about earlier in this video. After combining like terms, you are going to integrate. The next step is to plug the points of intersection values into the integrated equation. First, plug the upper bound into the antiderivative, and then subtract the antiderivative with the lower bound plugged in. Then simplify. This gives you that the area between these two functions is 9/2 or 4.5. Now we are going to do another problem. After drawing the graph, notice how there are two different regions bounded. For this problem, we will have to find the area of the two regions separately and then add them together at the end. Now that the graph is drawn, let's find the points of intersection. There will be 3. We are going to find these points the same way we did in the last problem, by setting the equations equal to each other and solving for x. After getting all the values on the same side and setting equal to 0, you'll find that the points of intersection are where x equals 0, 2, and -2. Looking at the graph at these points, you can tell that the first region is bounded by the points -2 to 0, and the second region is bounded by the points 0 to 2. I have now labeled the two areas, Area 1 and Area 2, to make it easier to follow along. We need to make two separate integrals for this problem, because the upper and lower functions switch at different areas. Notice that in Area 1, f of x is the upper function, and g of x is the lower function, and then they switch in Area 2. That's why we need two separate integrals. First, we are going to find Area 1. In this region, the function f of x curve is on the top, and the function g of x curve is on the bottom. Now set up your equation for Area 1 bounded by the points -2 to 0. Combine like terms and then integrate. Now simplify. The area of region 1 bounded by -2 to 0 is 12. We are going to keep that number in the back of our minds as we continue to the next step. This is to solve for the area of region 2 bounded by 0 to 2. If you look at the graph, you will notice that for region 2, g of x's curve is on the top and f of x's curve is on the bottom. This means that we will be subtracting the function of f of x from the function of g of x. The first step is to plug all the information we know into the formula we learned about in the beginning of the video. Then you are going to combine like terms and integrate. Simplify. Now we know that the area for region 2 bounded by 0 to 2 is 12. Now remember how I told you to put the area we found earlier for region 1 in the back of your mind? Well, now it is time to bring it forward. Now that we know the individual areas of each region, the final step is easy. Add the two areas together to get the entire area of the region bounded by the given functions. So after adding Area 1 and Area 2 together, we find that the total area of the region bounded by the given functions is 24. And now you know how to find the area of a region bounded by two curves.